Okay, so welcome to this class. This is our first class in math. We'll be looking at sets. Okay, so these are just questions from um, exam past papers for grade 12s. Okay, so meaning that if you're writing your grade 12 this year or you are rewriting, or meaning you're writing GCE, okay, this is a very good platform for you to learn. So our lessons will be mostly focused on solving exam questions. Okay, so we'll be explaining how to solve each and every exam question. Okay, so in this video, I picked out the questions from the exam papers that are on what? Sets. So we're going to solve 5 questions in this video. I hope it will be helpful to you as you are watching. Okay, and as we continue to learn, okay, until the time you're going to write your exams. Okay, so for those who don't know me, my name is Tutor Paul Solutions, and I'll be helping you with math and chemistry. Okay, and then my other colleagues, they will introduce themselves later on. They'll be helping you out in the other subjects. All right, so let's start with question 1 there. So question 1 is very simple. So on question 1, they're saying, given that E is the set that contains 12, 13, 14, 15, 16, 17, 18, 19, and 20. And then A is the set that contains prime numbers. Okay, B is a set that contains multiples of 3. List the set. Okay, list the set A union B complement. Okay, A union what? B complement. This one here. So here we first have to list down these sets here. What is set A? What is set B? In short, what elements are we going to put in set A? And what elements are we going to put in this what? Set B here. So the universal set has been given as the numbers 12 to 20. And then set A, they're saying it's a set that contains prime numbers from this universal set. Okay, so what are prime numbers? Okay, so prime numbers are simply the numbers that only have 2 factors, itself and 1. Okay, so what does that mean? It means when I get that number, okay, um, there's no any other number that I can divide that number with, and then it's not going to it's not going to leave a remainder. Okay, any number that I'm going to divide it with, apart if it's not itself or if it's not 1, it's going to give me a remainder. Okay, so for example, before you even pick the prime numbers from there, for example, if you get 3, okay, if I say 1 divided by 3, I get 3. Okay, if I take 3 divided by 3, I get 1. Okay, so is there any number such that when I divide that number, okay, I divide 3 by that number, I'm going to get an answer, like an exact number without leaving a remainder? No, because if I try 3 over 2, okay, this will just be 1.5. Okay, 1.5, it means the 0.5 there is a remainder. Okay, or we can say 3 into 2, it's 1, remainder 1 over 2. Okay, so there are no any other numbers that can go into 3 apart from 1 and 3. So for all those numbers that have this same property, that's such that, okay, there's no any other number that can go into that number apart from itself and what? 1, we're going to say that number is a prime number. Okay, so from the set that we've been given there, the prime numbers are simply 13. Okay, because 13, only 1 and 13 can go into the 13 without leaving a remainder. Okay, 14 here is not a prime number because 2 can go into there, 7 can go into there, 1 can go into there, even 14 itself can go into there. 15 again is not a prime number because 1 can go there, 3 can go there, 5 can go there, 15 itself can go there. So it has more than 2 factors. 16 the same. But when you look at 17, 17 is a prime number because only 17 and 1 can go into 17 without leaving a remainder. Okay, what about 18? 18 is not a prime number, but 19 is a prime number. Okay, only 19 and 1 can go into this 19 without leaving a remainder. So this is my set A. Okay, and then the other set that I want to list down is this set B. So set B said this is a set of multiples of 3. Okay, so multiples of 3. So what does multiples of 3 mean? Okay, it just simply means the numbers in this universal set here in which 3 can go into without leaving a remainder. Okay, so 3 can go into 12 4 times, remainder 0. It can go into 15 5 times, remainder 0. It can go into 18 6 times, remainder 0. So the numbers that are multiples of 3 there, it's just going to be 12, okay, 15, and then what? 18. So these are the multiples of 3 there. Okay, so they're the ones that we are going to put there. All right, and then now we can list whatever they're asking us to do here. So they said we list A union B and then complement. So first of all, we're going to list the set A union B, okay? And then the complement simply means we list all those elements that are not going to be in A union B. So A union B, it means we are combining these two sets here, okay, without repeating any number that is appearing twice. So the smallest number you can see it's 12, and then I have 13, and then 17, and then from there 18, and then 19. Okay, so this is my A union B. Okay, but there they said I should list A union B, okay, and then complement. So meaning all the numbers that I can see in the universal set here, apart from these ones here. Okay, so 12, no, 13, no, 14, yes, because I can see it here. So it's in the complement. Okay, 15, yes, it's in the complement because I can see it here. Oh, supposed to write 15 there. So this is 15, and then the other one is 16. Okay, 17 is there, so I don't write it here. 18 is there, so I don't write it here. 19 is there, so I don't write it here. So the other number there is just 20. Okay, so this here will be our A union B, A union B complement. Okay, are we correct here? No, we have missed out 15. Okay, so here we've missed out 15. So we've missed out one number. So it is 12, this one, and then 13, and then 15 there. Okay, and then 17, 18, and then 19. Okay, so we see that 15 is in the A union B, so it's not supposed to appear there. So we're going to erase it from this set. So we're going to say the A union B complement only contains 14, 16, and then the 20 there. Okay, so that's our A union B complement, simply meaning the elements that are not in A union B. Okay, so we move to question 2. This is question 2 here, and we're doing a similar thing. But the good thing about this one is that they've already listed out the A's and the B's for us. And this is the universal set. So they're saying list A intersection B complement. So first of all, we find the A intersection B, which will just be the common elements between this set and this set. Okay, so what is common between these two sets here? Okay, I can see I have 3 here, I also have 3 there. I have 6 here, I also have 6 there. So the intersection is going to have 3 and 2. Okay, but remember, this is not what I want to find. I want to find my A intersection B complement. So this one here is just helping me to find my final answer. So A intersection B complement will now be equals to, okay, A intersection B complement will now be equals to all the elements that I can see in the universal set, but they are not here. So it means the entire universal set apart from 3 and 6. So I'm just going to write 0, 1, 2, 3 is here, so I can't write it here. 4, 5, 6 is here, so I can't write it here. Okay, so I'll go to 7, and then 8, and then 9. So this one here is our A intersection what? B complement, meaning the elements that are not in the set A intersection B. Okay, so that's how we find the A intersection B there. Next, we are going to look at question 3, okay, which is similar to question 1. So here they're saying we list A union B complement. So first of all, we are going to find A union B. So A union B simply means we combine all the elements in set A and B without repeating any that is appearing in both sets. So there it will be 1, 2, 3, 4, okay, and then 5, and then 6. So this is my A union B. I've just combined everything here with everything here, making sure that those that are appearing in both of those sets there, okay, I'm just writing them once. All right, and then now I can find my A union B with the complement. So A union B complement simply means all the elements that I can see, okay, that I can see in the universal set there, but are not appearing in the set A union B. So 1 appears there, so I can't write it there. 2, 3, 4, 5, 6, they all appear in the A union B. So I can't write them here. So the only one that is missing there is the 7 and the 8. So these ones here are the ones that are not in this set. So they are going to be in the what? In the complement. Okay, so that was question 1, 2, 3. We now look at question 4. So question 4, they're saying on the Venn diagram in the space below, shade the region defined by A complement intersection B union C. Okay, shade the region A complement intersection B union C. So here we're going to use a very nice method, okay, in order to find whatever we want to find here. So we're going to put numbers in all these circles that you can see. So I'll say 1, 2, 3, 4, 5, 6, 7, and then 8 outside like that. Okay, so now I want to shade A complement intersection B union C. So first, let me find what B union C is. So B union C is getting everything that I can see in B and C. So this is the set C here. This is the set B. So if I combine those elements, okay, it will just be 2, 3, 4, 5, 6, 7. Okay, so these are the elements that are in B union C. And then I'm intersecting this B union C with the A complement there. So let me find, first of all, the A complement. So A complement simply means all the elements that I cannot see in A. So A is this guy here. Okay, let me, let me circle around it. So this is my A. Okay, so all the elements that are not in that red circle that I've drawn are in the A complement. So meaning 3, 6, 7, 8. 3, 6, 7, and then 8. Okay, so now what are we finding? We're finding A complement intersection B union C. We want to shade it. So first, let's find it. Okay, so we know that the intersection there simply means what is common between these two sets, right? So I can see 3. I can also see 3. I can see 6, 6. I can see 7. I can see 7. Okay, so that is what is common between those two sets. So I'll write here 3, 6, and then what? 7. So this is my intersection. Okay, so I'm only going to shade the part that has, okay, 3, 6, and 7. That is the only part that I'm going to shade in this Venn diagram here. So I'm just going to shade, okay, I'm just going to shade the part that had 3, 6, and then 7. So let me erase this red line here. Okay, so you can clearly see that the part that has 3, 6, 7 is just this part here. So this part, like this. Okay, so that would be my shaded what? Region there. Okay, so that's it. We move to the last question for this video, which is question 5. They're saying, using set notation, describe the shaded region. Okay, so here we just have to be a bit technical. So we see that here I have set S G, and M, right? And then this part here is the one that is shaded like that. Okay, so how can we describe this using set notation? So we first of all see that, okay, the shaded region is outside S union M. Okay, you can see S union M is this part here, or this part here. This is S union M. Okay, so we can see that the shaded region is outside that thing. Okay, so I'm just going to say S union M. Okay, but because in S union M, I can't see any shaded line, I'm going to say this is the complement. Okay, S union M has made a nice word here at sum. Okay, so this is S union M complement. And then we can see that the shaded is part of the set G. Okay, so I'm going to say intersection the set G. Okay, so that's what is going to describe this shaded region here. It's just the G intersecting S union M, or S union M complement intersecting G. Okay, because the shaded is outside the S union M, so we add the complement, and then intersection, meaning want the common part. Okay, it is just the G there, which is common with whatever we wanted to do. All right, so that's the answer there. Okay, so there you have it. So thank you so much for watching this video. This was our first lesson, okay, for the 2026 GCE exam preparations. Okay, so we'll be having lessons each and every day to prepare for those exams. Okay, so for those who would want to reach out to me for extra lessons and tuitions, my number is simply 0779 96 40 and then 10. Okay, so my name is Tutor Paul Solutions. Okay, so Paul Solutions if you want. Okay, so you can add the tutor on top there. So Tutor Paul Solutions, this is my number here. We are offering lessons for physics, chemistry, biology, math, science, and civic education. Okay, so thank you so much. This has been Tutor Paul Solutions. Until I meet you in the next video.